Hello and welcome to the world of NDE 4.0. My name is Vrana, and today is a great day because today I have the honor to open the Digital Twin Summit 2022 and to introduce the concept of NDE 4.0 to the digital twin community. Thanks a lot for the invitation, but before I really get to the topic of this talk, let me show you a little bit my path. I was always fascinated by technology. And therefore, already when I was a small child, for example, here, that was my 8th birthday, I got this piece of technology, this analog keyboard. And I was so happy on that day. And that led to me studying physics. I got into quantum optics and into quantum computers. And here you can see me standing next to this experiment. This was actually my master thesis. And in my background, you can see a small vacuum chamber where we had a single atom and where we proved for the first time the entanglement of a single atom with a single photon. And if you think about it, entanglement between a single photon and a single atom, that's kind of the basis. If you have two quantum computers and you want to have some communication between them, yes, then you need to have some entanglement between them, and that's where you need the photons and to have the then the connection between the quantum computers. Now, it was a very nice topic for my master thesis, but I wanted to do something which was more hands-on. And even that now quantum computers are becoming a really big topic, back in those days, I knew it was at least 20 more years to get to something where I would really like to work in. So therefore, what I did, I got into something called non-destructive testing or non-destructive evaluation, which in essence is physics applied on, or physical sensors applied on components. So here you can see myself standing next to this huge forging. And this is actually an ultrasonic inspection system for such large forgings. And to give you an impression, those forgings, they can be something like 300 tons of steels, something like 20 meters of a forging. And within those forgings, we are looking for imperfections of the size of a millimeter. So I guess you can already see what a powerful data source ultrasonic testing or non-destructive testing in general can be. And that was also the case where this was somewhere in 2014, some fracture mechanics specialists approached me and they wanted to have some more knowledge out of the internal structure of their components so that they could do a more accurate fracture mechanical calculation. And so what we did, we took all of the NDT data we had, we did a statistical analysis on all of them. And we really helped that project. We gave them exactly the knowledge they needed. And the business case for that project, for using the NDT data to actually enhance the fracture mechanics, that was a 9-figure number. So yes, that was a pretty good experience. And that actually brought me to the idea of NDE 4.0 and to using the NDE data for engineering purposes. Now, 2017 was really the year where I got into NDE 4.0, and I proposed to the American Society of Non-Destructive Testing that I would be chairing a session about NDE 4.0. They agreed, but they told me they already had somebody else who wanted to do the same thing. And that gentleman is Singh. And so for the first time, we met in 2017 at the ASNT conference. And actually, the two of us really got along well from the first point we met. And it became one of the most fruitful collaborations I had in my lifetime. And so finally, we ended up working a lot on NDE 4.0. And last year, the two of us together, we published this book, The World of NDE 4.0, Let the Journey Begin. Now, so far, so good to my story. Now, what is NDE, NDT, you might ask? Now, if we look into the past of NDE, NDT, yes, it's right from the beginning when people started to produce something. They want to know, is that what I produce? Does that have a good quality? So they use their human senses to actually, evaluate the component, listen to it, look at it, perhaps take a small hammer, bang on it, and see, is that something of a good quality? Now, pretty soon they used some simple tools to enhance their human senses. And then came really the analog technology, which helped to expand the human senses, like X-ray. I guess most of you will actually have seen this image of an X-ray. That was one of the first X-rays which is actually ever done. And what X-ray and also ultrasonic testing and all the other methods actually allowed, with expanding the range of our human senses, was also really a look into the components. So now we have a data source giving us information from the internal structure. Then we made the move from analog to digital. Like here, we have a huge ultrasonic inspection system, a digital ultrasonic inspection system for, again, a large forging. But now if we think about what are we classically doing with NDE, NDT results? We have all of that data, those gigabytes of data. We put them in some kind of a data processing. We use some CPU. We visualize those results. And then usually a human, depending on the visualization of the result, says, is that component good or not good? So he is doing a quality assurance assessment based on all of this NDT data. And he breaks down gigabytes of data to a 1-bit information, to a go, no-go decision. But if I think about what industry would really want to have in addition, they would want to have more knowledge about the component so that they can improve and optimize the design, the production, the maintenance. And what does that mean for NDE? Yeah, it means the shift from the binary QA decision to becoming an information source for engineering. Now, I guess most of you have heard about the 4 industrial revolutions and talked about all of that. But there has been a very similar development in NDE, and we can also kind of say we had 4 revolutions of NDE. And with each revolution, NDE and industry, they are really becoming closer and closer. And now with the 4th revolution, we are getting into a real combined NDE and industry, and NDE, from my eyes, becoming a really valuable data source. Now, what's NDE? NDE, for example, here. You have all been to a radiographic inspection or radiography at your doctor. And that's also what we do with the components. We can have an X-ray source and a detector, put a component in between and see what's within that volume. We can do an eddy current inspection. So with a tiny coil, we excite a small current, which we induce into a component. And again, with the same coil, we record what is going on in that component. And this is actually a very sensitive thing to measure what's going on in the surface of a component. Or we can do ultrasonics like we saw it before on those large rotor forgings. And yes, within a 300-ton shaft, we can find 1 millimeter or smaller indications. So that's really like looking for the needle in the haystack. But we are doing that every day. We can look into active thermography, where we use some excitation, like a flash or some induction, and then we actually record the thermal answer of that component with an infrared camera. And what we can see here, this is a blade from a big gas turbine. And what we can see is we can see from the out, so we have the infrared camera on the outside, and we can see with the active thermography, we can see all those cooling channels within the blade. And the different colors you see here on that blade, they actually give us the wall thickness between our surface and our internal structure. We can even go with ultrasonic testing. We can go one step ahead and do a reconstruction and get a real 3D reconstruction of all the defects we have in that component. Or we could do the same with CT, and that's, yeah, I guess most of you will know it also from the doctor, the computed tomography. Now, all of those methods are what I consider classic NDE. Now, there are more methods to classic NDE, but the methods I presented to you up to the moment, they are the highly digitized ones. There are others like visual testing or dye-penetrant testing or magnetic flux testing. Most or some of them are really for surface inspection, some of them are for volumetric inspections. And then we have all the reconstruction methods, which really give us a three-dimensional view into the component. And now if we look into what those methods can do is, yes, they give us quite high information content, but the system cost, the system complexity is quite high, meaning the inspection rate has to be quite low. So classic NDE is kind of here. Now, classic NDE, how I discussed it up to the moment, that's for me the first phase of NDE. But there is a second phase. And that's what I'd like to call non-destructive sensors. So that could be something like an accelerometer, which are those tiny chips we know from our cell phones. Or it could be an acoustic emission measurement, where we put them, let's say, on a bridge or on any other component, and then listen to what happens if a car is driving by and how that damages the bridge in real time. Or we could do something like passive thermography. So having an infrared camera, but now not actively giving power into that component, but just monitoring the heat created by or reflected by that component. And that's, for me, the second phase of NDE. All those NDE sensors. What we can also do, we can have also sensor arrays. We can even do reconstruction on them. But the main difference for me is we do not get an as high information content as we get on the classical NDE. But on the other side, our inspection rate can be way higher. It can be kind of real time. So this is why I would put the NDE sensors down here. If we think about it, yes, classical NDE, we could also call that active NDE because it requires excitation. And the sensors, yeah, they sense natural properties or events. So this is kind of passive NDE. And for me, to get a real holistic picture, we need both of those phases. Sometimes we need the high information content, and sometimes we need the high repetition frequency of those passive NDE sensors. Now, what do we as domain experts, what do we do with the data? Now, if we look into a typical feedback loop, like, yeah, I have done it during my PhD, you take some data, you put it into some data processing, you create some knowledge by visualizing that data, and you create some action out of it. At some point you think, oh, if I also take this data into account and let's add another data source, then I could learn more out of it. I perhaps add more processing, I add more data sources, I perhaps even add a fancy augmented reality or some other data sources or even an AI. And at some point, yeah, we kind of end up here. And kind of, once we have finished this, yes, every time we kind of have to start from scratch. So what we really need to have, we need a different solution as domain experts. We need a different solutions to integrate our sensors into something which can process our data in a better way. And this is why the NDE 4.0 community has started first actions to implement NDE into the IIoT. And we want to fuse that data. We want to make out of the data information. And we can do that by giving that data structure, by making that data machine readable, by converting that data to information. So, and this is an example I like to give during my presentations. If I now show you the next slide, you will immediately know what that information is about. But if I enter this number into a computer, if I store that information into, some program, that program will have no clue what that number means. Now, even if I have really good programming, which then perhaps looks up Wikipedia, what the number 42 means, I think Wikipedia currently has 107 different meanings for the number 42. And if I think about it, the number 42, that could also be the length of a truck. That could also be my weight in kilograms. But actually the question is, which year was that? Or it could be the gain of the UT instrument. And if it's the gain of the UT instrument, we need to know, was it before or after calibration, at which day, and so on. So we need all kind of the surrounding metadata associated with our main data so that we can make out of the data information. And once we do that, then yes, the computer might know that this is actually the answer to the ultimate question of life, the universe, and everything, at least Douglas Adams' book, Hitchhiker's Guide to the Galaxy. Now, because we as an NDE community have the feeling that we have to convert our data to information, and that this is really what our future customers want from us. This is why we started to integrate NDE into the IoT by actually developing an OPC companion specification. We already also are talking about, developing a semantic interoperability model for the AAS, for the asset administration shell. And I think there will be a talk a little bit later today. Now, once we have that, then we can actually take this information and feed it into a digital twin. And then the digital twin community can use that data, which in my eyes is so incredibly valuable. Now, if we look at those cyber-physical loops, they can be small, they can be big. And we can identify multiple of them during the lifetime of an asset. If we'll think about the lifetime of an asset, we have a first idea for some asset, we design it, we have some supply chain. Within that supply chain, we usually have already a first production inspection. We get into assembly, we sell that component to some owner operator, it's operated for a couple of years, we do some service inspection, and at some point we go into an end of life. Now we have NDE at some places, like here in production inspection and service inspection. We also have some NDEs, perhaps sometimes to enable circular economy. And we can have little feedback loops where we take the NDE data, we pipe it into an AI, and we get more out of it. Or we take the NDE data, we use some kind of a mini digital twin to actually, really tailor the NDE inspection or to improve the NDE inspection to, our situation. And that brings some benefit. But we can think bigger. And we also have a lot of sensors installed. Raw material production, component production, in assembly, in operations. That's where we normally call it either structural health monitoring or condition monitoring. We can use that sensor data for sure to do something like a predictive maintenance. But we can go bigger. We can take, for example, the NDE data and have it feedback all the way back to design. Or we can combine that NDE data with the data of all kinds of sensors and then have a feedback to design. Similar here, if we think about the maintenance side of it, we can take the NDE data, put it back to operation, or we can even take the fuse data to get a more holistic predictive maintenance, perhaps even a prescriptive maintenance. For sure, I can also take that data to put it back to design and perhaps fuse it with all the other data sources, or even take the data from the end of life. So I hope that now you can see why I think that NDE, both the sensors and the classical NDE, are such a powerful data source. Now, I know from speaking to a lot of people that some people think that classical NDE is nothing we need nowadays. But in my eyes, if you think that way, then you're using NDE wrong. Because in that case, you're just using it as a quality assurance yes and no decision. But for me, NDE data has such a bigger value if we use it in combination with the sensoric data to actually have a feedback to design. And what we can do for sure is we can reduce the number of classical NDE inspections. But actually, what a classical NDE does, this provides the ground truth, and we need to have that from time to time. And then we can use all the sensors in between which provide the feedback. Now, and once we do that, once we have this holistic view, integrate both the phases of NDE, then we can really support all the digital twins along the value chain, along the digital thread. We can even support the digital thread with our data. We can also support all the different hierarchies of digital twins we can get. So in essence, we kind of can really support all the digital twins and what we like to call the digital weave. Now, a little bit more in-depth information, if you want to have it, we have written 3 peer-reviewed papers. One is really about the basics of NDE 4.0, where we use a design thinking perspective to get into NDE 4.0. We then did a technical deep dive into the industrial Internet of Things, into digital twins, into whatever. And then we got into value creation, what value you can get through NDE. We've also written 2 books. There's on the one side, there is the handbook of NDE 4.0, which is actually a 1,400-page document where we were some of the the editors. Now, it's not the book you want to really buy. It's more the book you want to get from a library, because the cost point of that book is about $800 or 800 euros. But we have also created the World of NDE 4.0, which is way more reasonably priced and which is available on Amazon. Also, I'm trying to do a YouTube video about once a week where I get into all the different topics about Industry 4.0, about digital twins, about NDE 4.0, kind of a connection between the, I would call it, Industry 4.0 communities and the NDE community to get both of them working together. I've also done a lot of videos about the different data sources and so on and so on. And in October 2022, we will actually have the first international conference on NDE 4.0 in Berlin, in Germany. And I really hope that I will see some people out of the digital twin community also at our conference. So thanks a lot, and I hope I will see you all soon.